Hello, welcome to section 8.2, and this is our second video. My learning targets are missing, but today we will talk about negative exponents. We'll also divide, and we'll also talk about zero exponent. So negative exponent, move. Before I actually start this, in mathematics, we never leave answers with negative exponents. Just like if you leave, for example, 5/10, you are expected to simplify and you are expected to leave this answer as 1/2. Same thing in mathematics, we never leave answers with negative exponents. So what is the shortcut? Move numerator or denominator. Okay, so here I'll show you what I mean by this. A to negative n, to make it positive, you move a to the n to the denominator. Okay, and now this becomes positive. If the negative exponent is already in the denominator, you basically move it up. So this will become 1 times a to the n, which becomes just a to the n. Okay, now let's look at some examples so you can actually understand this. So question number 1. What I recommend doing here is actually putting 1 in front of it. 1 times x to negative 1. Okay, so 1 stays where it is, times, and how can I rewrite x to negative first? This becomes 1 over x to the first. What is 1 times any number? It's the same thing, so the final answer is 1 over x. Question number 2. Negative 2 times, and how do I rewrite n to negative second? N to negative second is really 1 over n to the second. So this becomes 1 times n squared. Now you can always put 1 underneath. And how do you multiply fractions? You multiply numerators, you also multiply denominators. So the final answer will be negative 2 over n squared. Okay, let me also circle this final answer. Question number 3. Negative 3, you bring it down, times x to negative fourth will become 1 over x to the fourth. So the final answer will be negative 3x to the fourth. In example number 4, again, I recommend rewriting negative n to negative third as negative 1 times n to the negative third, which becomes negative 1 times 1 over n cubed, which becomes negative 1 over n cubed. The second part of the lesson is zero exponents, which is actually a very interesting fact, because anything raised to the 0 power is equal to 1. Anything raised to the 0 power is equal to 1. In theory, if a is 0, 0 to the 0 is actually not 1, and that's a calculus topic, but anything raised to the 0 power is equal to 1. Okay? So xy to the 0 power simply is equal to 1. Now this huge number, 5 million with something raised to the 0 power, is also equal to 1. Just be careful. I just want to show you something. If you, for example, have negative 3 raised to the 0, negative 3 raised to the 0 in parentheses is equal to 1, but negative 3 to the 0 without parentheses, it's actually equal to negative 1. And why? Because this means negative 1 times 3 to the 0. According to rules of PEMDAS, or operation, you do exponents first. So this will be -1 times 1, which is equal to -1. Again, be careful because this is a very common mistake. So the second part of the lesson, or third part, is dividing powers. Okay, when we divide, we actually subtract. If you recall the other example, when we did 2 squared times 2 cubed, multiplying, we are adding, dividing, we are subtracting. So this was 2 plus 3. Okay, so in this case, we will subtract. So the rule is a to the m over a to the n is a m minus n. Okay, so example number 1. We have basically same basis. So what is k cubed over k cubed? Now you may think about this. Any number divided by itself is equal to 1. If you think about any number, divide a number by itself, you get 1. But mathematically, why is it 1? Because this means k 3 minus 3, and you know that this means k to the 0, and k to the 0 is 1. So this will be -2 times 1, and the final answer is -2. Okay? Now, second example. Let's look at the coefficients first. So you get -4 over 2, which is -2. So this becomes -2. Okay? Then you have x cubed in the denominator, so I will leave it. Why do I leave it? Because there is no other x. But we also have y to the 4th over y cubed. So y to the 4th over y cubed will be y 4 minus 3, which is equal to 1, which is technically y. So that y stays in numerator. How do you know it's in the numerator? Because it's technically over 1. So this is your final answer. Now, before you leave this, ask yourself, do we have any negative exponents? No, the answer is no. We have -2, that's a coefficient, but we don't have any negative exponents. So the final answer is -2y x to the 3rd. Okay? And finally, question number 3. The denominator can be written as -1 x y cubed. Okay, so first question is, what is -2 over -1 is equal to 2. Now z in the numerator, but no z in denominator, so leave it in the numerator. I have x cubed over x. So x cubed over x, you can write x as x to the 1st. 3 minus 1 is 2. So that will be x squared. Okay, and now you also have y 4th over y cubed. Y 4th over y cubed is y4 minus 3, which is y. So this is your final answer. 2z x squared over times y. Okay, finally, the fourth part of the lesson is power of a quotient. Raise each base to the n power. So this means a to the m over b to the m. Okay, so question number 1, you can think about v to the 9th over v to the 9th. Since I have the same base, I can do v9 minus 9, which is v to the 0, which is equal to 1, because any number to the 0 power is equal to 1. Question number 2. You can rewrite this as 2a cubed to the second over a to the second. Now the numerator becomes 2 squared, which is 4. A cubed to the second is a to the sixth. And the denominator becomes, just still stays, a to the second. Now, if you use the quotient rule, this 4 stays 4, and a to the sixth over a to the second becomes a to the fourth because we are subtracting. So your final answer is 4a to the fourth. Okay, in question number 3, x cubed stays x cubed. Now the denominator becomes x to the 12. Now, when we have the same basis, we can subtract the exponents. So this becomes x3 minus 12, which becomes x to negative 9. And again, be careful, because we cannot have negative exponents in your final answer. And we're going to use this rule. A to negative n is 1 over a to the n. So your final answer will be 1 over x to the 9th. Just so you know, some of the problems can be solved in a different way. So just because I did it this way, if you have another approach, most likely that's fine. Just ask your teacher. But again, many of the problems I'm presenting here can be solved in a different way. All right, finally, question number 4. Okay, first I am going to rewrite x squared to the third as x to the sixth. Now, you can apply the power rule, but you can also first rewrite what's inside of parentheses. X to the sixth over x to the third means 6 minus 3, which is x to the third. So what's inside of parentheses is x cubed to the fourth. Okay, and now I will multiply, so the answer is x to the 12. Again, good exercise is to solve this problem in a different way. So thank you for watching this video.